I'll give you 3 minutes to try this problem and then we'll go over it. It's the first problem on the back page. Back page from yesterday, top problem on it.
Was it top row 0?
Top row is 0. The first row first. Just the number 1, right? The number 1 is the 0th row. Then 1, 1 is the first row. 1, 2, 1 is the second row.
Like this, running the
Equation? Yeah. Yeah.
isn't the range, the range like the
Y values, smallest to largest. Make sure you remove any asymptotes. Is that calculator allowed?
you did this in pre-calc?
Yeah, that's a pre-calc thing. Is that calculator allowed? You could use a calculator. Graph it and then look at the Y values. Okay. There are 2 ways you could do this problem. You could use Pascal's triangle. I'm going to do this with the new method we learned yesterday. So you could expand this by doing the following trick. You'll do a combination of 4 to 0, x to the 4th, negative 2y to the 0, plus 4, 1, x cubed, negative 2y to the 1st, plus 4, 2. I think I might run out of room. X squared, negative 2y squared, plus 4, 3, x to the 1st, negative 2y cubed. I did run out of room. Egg, plus 4, 4, x, negative 2y to the 4th, x to the 0. That combination 4, 0, 4, 1, 4, 2, 4, 3, 4, 4 will tell you the coefficients from Pascal's triangle. I wonder if you could do these in Google. 4C0. No, it won't do it. 4 NCR 0. Nope. Oh, well, there's a combinations calculator. You can just plug them right there. Otherwise, you just grab your calculator and you're going to type these in. The first one is just 1. Right, 4 combined zeros, x to the 4th. And then negative 2y to the 0 is also 1. 4 choose 1 is, now that one you might need a calculator for. Oh, probably not, to be honest. You get 4 x cubed negative 2y plus, if you do 4 NCR2, you get 6 x squared 4y squared plus 4 x negative 8 y cubed plus 1 positive 16 y to the 4th. Okay, I'm going to pause. That's an important line. Does everyone see how we got all these numbers? Is there a number up here you're looking at and you're like, how did you get that number? Everyone's okay with where this 6 came from? I mean, yeah. But if you apply a 4, x to the, and you apply 4, it's x to the 4th. X to the 3rd, x squared, x to the 1st. X to the 0 is the only one that you can really evaluate, right? X to the 0 is 1. Oh, to the not the numbers in front, not these ones. The ones you get from the coefficients, you do not apply. Which, if you check your P-Square's triangle, which is the other way to do this problem, this is the 0 row of Pascal's triangle, first row, second row, third row, and then our 4th row, the one we want, is 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Yeah, Miles. Yeah. Did you say why does that change from a fraction? Oh, subtraction to multiplication? That's the definition of your binomial, because when you're distributing, right, you're always taking like first term times the second term in the sentence. That's a great question. And when it is subtraction, you have to be very careful and write it like we did, where you put the term in parentheses with the negative sign, because negative 2 squared should be positive 4. All right, then we got one last simplification. I'm going to multiply these numbers together. So I'll get 1x to the 4th, -4 negative 2 minus 8x cubed y. Done? A little bit more? It could be. I don't remember what the answer is. It might be that, actually. I don't know. It's something like that. 6 times 4 is 24. X squared, y squared. And then 4 times negative 8 is negative 32. XY cubed. 1 times 16 is 16. Yeah, where you going? Which teacher?
James.
Oh, yeah. He'll want to pass. Okay, how do we feel about that bell work question? Do we want to do another one of these? What is the next slide another one of these? I think it is. It is another one of these. Okay, so before we have you try this one more time, Are we okay with how we got from this second line to the third line? That's just simplifying, multiplying, 4, -2, and all that stuff.
Hold on. I'm gonna take a picture.
Okay, you take a picture of
I'm gonna
this.
show you this on.
Well, I wish I wouldn't have messed up this part then. So it could have been one line.
Look how good this shit is.
Well, except that part right there. Okay, let's have you try this one, okay? I want to scaffold this at all. I want to scaffold it at all. Okay, let's scaffold. How do I want to scaffold it? I think let's do this. Here's how I want to do it. I'm gonna run out of room again. I get so excited. Hold on. I'm gonna start over before I mess this up. Okay, fill in those blanks. That's what I need. What goes in those blanks? I'll give you 1 minute just to fill in the blanks. And there is a pattern. There's a pattern, right? You should see a pattern to how these blanks are filled in. Okay, I'm gonna give you 30 seconds. Yeah, 15 seconds. 15 seconds to look at a neighbor's paper before I call on someone randomly to tell me these numbers in this pattern. Noelia, what goes here?
Just so you know, if she gets it right, she wins her paper. But if she did it, it wasn't my fault.
Okay, got it. So you're to praise or take no blame.
Right.
Got it.
So I think I know. I think I know.
What do you got?
Would it be 1 and 2?
How about 3 and 0?
Wait, 3, right. 3 and 0.
Because the power is 3. And then we're going to choose the 0th number. Remember, you got to start at 0 when you're counting. So what will the powers be?
Wow. That'll be either. What if it's 1, 2, 3?
You start the first one at the highest power,
3, 2.
and then you start the second one at 0. Very good. All right. Do you see the pattern? Do you see how these numbers match with these? What's the next one?
3.
1. Okay, now what happens to our lead power? It goes down. It descends. What happens to the second power?
It goes up.
It goes up. So now notice the bottom number still matches, but this will always be 3. This one will descend.
Okay.
What's the next one?
2. 3, 2.
3, 2. What's my powers?
6, 1, 2.
1, 2. Last one.
3, 3. 0.
No, 3, 3. You were right. You're right. 3. I was doing 3, 0 because it's the same answer. 3, 0 and 3, 3 are the same thing. They're both 1. You're right. It was 3, 3. I messed you up. My bad. All right. What's the powers?
And then it's 0, 3.
0, 3. You're good. Good, good, good. Good job. Okay. The next thing is calculator work. Tell me what is 3Z0, 3C1, 3C2, 3C3. And then what is 4 to the 0, 4 to the first, 4 to the second, 4 to the third. So next scaffolding. This will be 0 something x to the something times something. Is this scaffolding really helping at this point? I don't know. X to the something times something plus something x to the something. Why did I put parentheses on that one and not the others, huh? Times something plus something, something, something. Great. That's good scaffolding right there. Scaffold that up. Get some scaffolding. 1 minute. Calculator work. Tell me what that stuff is in your calculator. Or you can use Pascal's triangle. If you'd rather use Pascal's triangle, you can use Pascal's triangle.
I'm not 100% sure I did this right.
That you did it right?
Didn't do it right, but
Here's your answers. 1, 3, 3, 1. As your coefficients?
Yeah.
You did it right?
yeah.
And then I assume if you did 4 to the 0, right, and 4 to the first, 4 to the second, 4 to the third, if you did the powers of x, right, x squared cubed is really x to the what?
X is 6.
X to x squared to the third power becomes x to the what is it?
I was just testing.
You were testing
I
me.
was testing you.
I
See if you were awake.
what is x squared to the third power?
Yeah.
All right.
Yeah, I was just testing.
Calculator work. Let's see who's got the calculator work to back it up. It's almost Canaan, but not quite. It's actually Miles. What is 3, 2, 0? Trent, hold on, so Miles can hear. What's 3, 2, 0? 3C0. It's 1. What is x squared to the third power? What is 4 to the 0? Yes, 1. What is 3, choose 1? Yep. What is x squared to the second? What is 4 to the first? What is 3, choose 2?
Wait, why is I'm so confused with these threes. Why is x squared 4?
3, choose 1 is 3 factorial over 3 minus 1 factorial times 1 factorial. But you also just do that in a calculator. You find probability option 3, third button in the probability column.
Why is this squared x squared? Right, just keep going, we'll get the answer.
Okay. What's x squared to the first? What's 4 squared? What's 3 choose 3? What's x squared to the 0 power? 4 cubed. I have a 1.
64.
X to the 0 would be 1, because anything to the 0 power is 1. And then 4 cubed is 64. Is that right?
Yeah, 64.
By the way, this is kind of a preview for tomorrow's class, but you can actually do some of these in your head. The 3C zeros. You don't actually have to do this factorial now. When I say 3 choose 0, I have 3 presents. How many different ways can you pick 0 of them? 1. I have 3 presents. How many different ways can you pick 1 of them?
3.
I have 3 presents. How many different ways could you pick 2 of them? Well, you could pick the first 2, the first and the third, or the second and the third. So 1, 2, 3.
Do you do that often?
3 choose 3. I have 3 presents. How many different ways can you choose 3 presents?
That's
1. You take them all. It really is. C stands for choose. Okay, and then we're just going to simplify this. The old simplification here. This just becomes x to the 6th plus 12x to the 4th plus 48x squared plus 64. Done. X to the 4th, because it's x squared squared. X squared to the 2nd power. No
Oh, I
problem.
actually didn't like. I forgot to do that.
Whatever.
Good. All right. Are you happy? I think we could be done at this point. I have more problems, but I don't know if we have to do them. There's smaller versions of this. Like for the next one, to find the 6th term of this sequence, a plus 2b to the 8th. You don't have to be scared. It's just a math problem. Do we feel okay on how to do this? No?
No,
Are you saying yes?
no,
It sounds like you're saying no.
yes.
Okay. All right, let's do it. Okay. The key part to this one is, okay, we're going to start writing it out and then we're going to stop. Okay. So this will be 8, 0, a to the 8th plus 2, plus, who put plus in there? Times 2b to the 0. That's the first term, right? Right?
Okay, yeah.
Okay. The next term would then be 8, 1, a to the 7th, 2b to the 1st. Right? That's the second term. So then the 6th term, if we're following this pattern, is 8 to the 7, 8 over 7.
Oh, we're going to
You
6.
see, because the first term starts at 0. The second term starts at 1. The 6th term will start at 7.
Oh.
A to the 1st, 2b to the 7th. Again, these powers match. And they have to add up to 8. So what number plus 7 is 8? So this is the sixth term. If you have 8 presents, how many different ways can you choose 7 of them?
Wait,
8 different ways, because you're just not picking one present, right? If I have 8 presents, I say pick 7 for you to have. I'm gonna keep the last one. There are 8 different ways to pick that, because you're just choosing a different present to not get.
But the way you're asking, it makes it seem like the order matters.
Ah,
So that's
but the order
why-
doesn't matter, right? That is a great, you all are previewing tomorrow's class so well. That's called a permutation rather than a combination, where the order matters. To do that, I have to stop sharing my screen, which gets rid of the annotations. Let me finish it and then I'll go show you how you get that.
I guess.
So that's 8a. What is 2 to the 7th? 1,000 billion, 128. Never mind. That's not so big. Yay?
Yeah.
Okay, I'll pause, give everyone a chance to write that
No, my factor was.
and all of its details.
Why did yours say 1? Oh, mine says 1.
Is the next one the one you have to do?
Yeah.
Find the 5th one?
Yeah.
Yeah,
Oh, yeah.
that's the one you have to do. Okay, how we type that into the calculator again? Does anybody need more time to write? I'm holding up. Because if I clear this, I can't get it back.
So why,
I'm waiting.
why is the 6th term 8? Why is 9?
Because every row in Pascal's triangle has one more term than the row. Remember? So like the first row, the 0th row has 1 term. The first row has 2. The second row has 3 terms in it. So you have to add 1 to the bottom to get the term, because the first term is the 0th power.
I'm still learning.
That's the thing that messes people up the most, is having to start counting at 0.
Okay, I'll choose the other thing.
Yeah. And then the bottom, that denominator is the power of the second term. And then the 2 terms have to add to 8.
So we switch and, okay, that's so.
Yeah. If you want to go into computer programming at all, starting counting at 0 is a big deal. Because certain programs start counting at 0, certain programs start counting at 1, and learning, how to use both and all that.
I just like it.
That's what I want to show next. But before I do that, I have to clear this. Got it? Okay, stop share, reshare, whole screen, calculator. How do we type in that? So you hit math, go right to the probability column, and it's option 3. For some of your calculators, it won't ask you to fill in the blank. For this one, it does. So it's 8, choose 7. It's 8. If your calculator does not look like mine, you might have to do 8 math NCR, then 7, enter. You might have to type the 8 in first before you grab it in the calculator, the NCR function.
So we type in the fraction first.
Type in the first number first, the 8, math, probability, option 3, then the second number 7. And that gives you that parentheses, 8/7, because that's 8, choose 7. All right, your turn. Last thing we're doing today. find the fifth term of a plus 2b to the eighth, and find the coefficient of this term in this expansion. Would you like some scaffolding? Some scaffolding? That's your scaffolding for the first one. You got to fill in those 3 blanks. There's some scaffolding for you. Get some scaffold in there. That's negative 5b. You knew that. Here, I'll fix it though.
Yes.
That helps. That helps.
That's amazing.
Yeah?
I saw that this morning. in orchestra.
Negative 5b?
No, it's negative 5 half.
Negative 5 half now.
Yeah. It's amazing.
What instrument is that?
Music.
Yeah?
Yeah.
Oh, just the half. Oh, just the B part. Okay, I'm picking up. what
Yeah.
you're down.
Yeah.
I'm like, what does that mean? I have to go down 5 octaves
I
and
was
then
looking-
use the first half note?
You said what instrument is that? I'm really confused.
I was wondering if there's a different one that had like some sheet music that instead of doing, bars, had in terms of coefficients of notes.
It's weird.
But I don't think that's true. They like the bars. Right, Matt?
Yeah. I love it.
Always 4. Always 4. No, I keep going. A neighbor that we practice out. Calculator. 11. Oh, yeah. Math, that one. Yep. We got 250 here. And then you'll need to tell me what 2 to the 4 that makes it 5 to the 7 is. So times 2 to the 4 times 5 to the 7. Make sure. When you do the negative 5, it's in parentheses. Times 16. Well, I mean, do it full. Got this times now we're gonna times that by negative 5. Parentheses. Negative 5. Close parentheses to the 7. Close parentheses to the 7. It won't matter if this was 2 powers off. There you go. That's the coefficient. It's that a to the 4th b to the 7th. Assuming, of course, it is, which you probably do. Right. All right. While I'm answering this question, you should look at the neighbor's paper or text. I think they've already been. Oh, I see. Yeah. A is from the 827. 826. What is 8 CR6? 8, oh, 20, so the 28 will go through that. But, yeah, I know. 8, 6. Should be A to the second to B to the sixth. Exactly, yeah. So by the time you get to that one, the last term will have power of 6. Notice that that matches 0, 0, 1, 1, 2. So that should be, yeah. Oh, wait, no, never mind. I'm sorry. That should be, that wasn't the sixth term. We skipped. But yeah, this power, this number is the power of your second term. And then they have to have. Come on, eight. There you go. A squared to be this. All right, let's go over this. Last thing we're doing today. You'll have the rest of the hour to work. And to help us do this is gonna be. What number goes right here? It's not 5, but it's pretty close to 5. No, other way. Add 1 to it, 6. If this number is 6, Mason, what's this number? Yes, which means what does A have to be to the power of? Yeah. How about 2? Because 2 and 6 add together to make 8. Okay, what is 826? If I have 8 presents and you can only pick 6 of them, how many different ways could you do that? That is actually kind of a hard problem. You might want a calculator for that. You should get, it is 28 different ways. A squared, what's 2 to the 6? 64. B to the 6. And then if we combine the 28 into 64, 28 times 64 is 1,792. A to the second, B to the 6th. Clear as mud? Yes, good, good. All right, let's do one more of these. Is that Nolan? 1, 2, 3, 4. That is a Nolan. All right, Nolan. I didn't write it. What is this number here? 11. All right, what is this number down here? Yeah, see that? See that? Which means this is, and then this is. Okay, if you have 11 birthday presents, 11 presents, and you get to pick 7 of those presents to take home for your birthday, how many different ways can you choose 7 out of 11? Good luck doing that without a calculator. 330? 330 different ways to pick your presents. That's a lot. All right, what is 2 to the 4th? 16? 16. A to the 4th. What is negative 5 to the 7th? Negative 78,125, you say? That sounds right to me. Negative 7,825. And so if we multiply those 3 together, we get, that's a lot of, that's a big number. Oh, wow. Negative 412500000. Negative 412 million. A to the 4th, B to the 7th. Okay, now when you're typing this into WebAssign, if you type this in, you'll get the wrong answer. Because what did it ask you to actually find? It just wants the number. So be careful how it's asking you the question. It just wants the coefficient, negative 412.5 million. Did you ever think that you would be in a math class where the answer to the question was negative 412.5 million? Walking into class today, answer's negative 412.5 million. All right, that's it. That's the class. You have the rest of the hour to work or play chess. Oh, wait, some of you have already started that. Yahoos. Yahoos. And then on tomorrow's class, I believe the lecture should only take half the hour. So you should have like 45 to 30 minutes to work tomorrow.